A warm, very happiest day to all. Myself, Sharmila from Assistant Professor, Department of Information Technology from Madurai Suvasinada's Pioneer Meenachi Women's College, Puvanthi. Today I am going to talk about database management system. The subject code is 7BIT5C1 BIT5C1. From unit 3rd, I have taken the topic database system architecture. So in this topic, we have to cover centralized and client server architecture, server system architecture, and parallel systems, distributed system, at the last network types. So we have to go through in these slides centralized and client server system architectures, parallel systems, distributed systems, and then network types. So these topics are covered in the unit 3rd. So first we have to see what is centralized system. So centralized systems means which run on a single computer system and which do not interact with other computer systems. So which is a general purpose computer system which systems have one or some few CPUs and which contains a number of device controllers that are connected through a common bus that provides access to shared memory. So depending on the number of users, it divided into two categories. So first one is single user system. It can used by only one user. For example, personal computer system and personal workstations are comes under this category. So desktop unit and also personal computers or comes under this category. So a single user can work on this system. Usually it has only one CPU and one or two hard disk, and the OS may support only one user. Another one is multi-user system. So it can work with more than one user. It has more disk, more memory, multiple CPUs and multi-user OS. So it serves a large number of users who are connected to the system via terminals, often called server system. So this is a centralized system architecture's basic concepts. So centralized system means run on a single computer system only, which do not interact with other computer systems. So now we have see the structure of the centralized computer system. So which use the shared memory. So the all devices are communicate through the shared memory. So they are connected through the bus. So the bus is nothing but which is the set of wires. So CPU, disk controller, USB controller and graphics adapter. So all these devices are connected through the bus with the shared memory. So this is the architecture of the centralized computer system. Now we have to see client server architecture. What is client? What is server? First we have to see what is client and what is server. So the client is nothing but the system request service which is called the client. So the system request service which is called the client. So the responsible system which is called as server system. So that are generally specified as here. Server system satisfy request generated at M client systems. So whose general structure is shown in this figure. So a server, a single system satisfy request of M client systems. So the client and server are communicated through the network. So which is the structure of the client and server. So based on the client server architecture, the database functionality can be divided into two categories. First one is backend, another one is frontend. What is backend? What is frontend? So the backend means we have generally specified backend as the database. So the databases are specified as the backend. If you have to do the project in 3rd years, which is the main question, which is backend, which is frontend. So which database system is used, that is called as backend. For example, MySQL, Oracle, so those are specified as the backend. Front end means which program you have to use to specify the form. We have to design the web. So that are specified in the front end. For example, any program, .NET, ASP, any language, C, C++, Python, PHP, those are all front end. So the databases are backend. So the backend manages access structures, query evaluation and optimization, concurrency control and recovery. So next we have move on to front end. What is front end? It consists of tools. Already I said it consists of tools such as forms, report writers and graphical user interface facilities. All those things are front end. So how is it communicated? So the backend is the database and front end is the programming language. How it will be communicated? So the both the front end and the back end are communicated through the interface. So interface between the front end and back end is through the SQL or through an application program interface, any application program interface. So in this diagram, so the front end have the SQL user interface, forms interface, report generation tools and the data mining and analysis tool. The backend has the SQL engine. So both the front end and back end are communicated through an application program interface. For example, if you have to use the Java program, means you have to communicate with the database through JDBC. So JDBC means Java Database Java database connectivity. So if you have to use another languages, some other languages other than Java, means we have to use ODBC, Open Database Connectivity. JDBC, Java Database Connectivity. Other than Java, we have to use ODBC, Open Database Connectivity. So what is the advantages of using this type of client-server architecture at the time of replacing the mainframes? What are the advantages? Means, so first one is better functionality for the cost. So for the cost which provide the better functionality. Next one, flexibility in locating resources and expanding facilities. Third one, better user interfaces. We have to, so much of languages give the user interface, betterly give the user interfaces. Easierly we have to maintain those. If you have to problem in backend, we have to individually rectify the backend problems. If you have to problem in front end, we have to individually consider on the front end. So it will be it will easier to maintenance. So next we have move on to next architecture, server system architecture. So the server system architecture, it also can be broadly categorized into two kinds. So the first one is transaction servers, next one is data servers. So the transaction servers are widely used in relational database systems, and the data servers are mainly used in object-oriented database systems. So what is relational database system? So it will maintain the database as the table format. It uses the table format. So data servers which use the object-oriented database systems. So that means the object-oriented concepts comes under these categories. Inheritance, polymorphisms, those categories comes under this database systems. So first we have to see transaction servers. So the transaction servers, also called as query server systems or SQL server system. So in transaction server, what the process are done here means the clients are send the request to the server, transactions are executed at the server and the results are shipped back to the client. So the process are done in the servers only. The client only receive the result and shown the result only. So the process are done in the server only. So the requests are specified in the SQL and communicated to the server through a remote procedure called mechanism. So the transactional RPC allows many RPC calls to form a transaction. So the already I said open database connectivity is a C language application program interface standard from Microsoft for connecting to a server, sending SQL results and receiving result. So the JDBC standard is similar to ODBC for Java language. So what is the process of transaction server? So these contains in the transaction server process structure. So here in transaction server all the processes are done by the server. So it specifies server process and the log manager process, database writer process. So the typical transaction server consists of multiple processors accessing data in shared memory. So it uses shared memory. So server process, all the processes are done in this server only. So the result will be come back to the client. So this receiver uses queries, transaction and execute them and send results back to. So process may be multi-threaded, so which allowing a single process to execute several user queries concurrently. So the typically multiple multi-threaded server process are done here. So the next one is log manager process. That means if you have to use any process done by the server, so that process will be logged. So for if you have to use the log manager process, we have to log the some process. If you want to used by another process, we have to wait because the process is logged by the one system. So for that reason we have to use log manager process. Next one is a database writer process. If you have to update the data, so using that we have to data will be updated in from the, if you have to modify any data from the client side, we have to update in the server database also. So if you have to modify the data in the client side, we have to modify the data, same data in the server side also. So that we have used database writer process. To avoid this, we have to use log manager process. So next also we have log writer process. Who are accessing the data we have to we contain. So those data which person access this data, so those we have to known by log writer. And also checkpoint process. Some periodic checkpoints performs to watching the process, any problem will be occurred or not. So that will be checked by the checkpoint process. So next, and also process monitor process, so which is monitor the other process and it takes recovery access if any of the other process fail. For example, if you have to abort any transaction being executed by a server process and restarting it. So this is the overall structure of transaction system process. So the shared memory contains the buffer pool, query plan cache, log buffer, log table. So server process are communicate with the shared memory. So the user process and server process are communicate through the interface ODBC or any JDBC. So database writer process update the data from data disk in the data disk. So log disk have the log writer process and periodically checkpoint process also available. So both are communicate the log buffer. So process monitor process to monitoring the process and also log manager process will be available. So these are the it is the transaction server architecture model, general architecture of transaction server system. So already I said that shared memory contains shared data and also it contains the buffer pool, log table, log buffer and also cached query plans. So all database process can access shared memory. To ensure that no two processes are accessing the same data structure at the same time, database system implement mutual exclusion using either one of the cases, that may be operating system semaphores or atomic instruction such as test and set. To avoid overhead of inter-process communication for log request or grant, each database process operates directly on the log table. So instead of sending request to log manager process, you have to log the table. So log manager process still used for deadlock detection. So which is used for deadlock detection, log manager process. So next we have to move on to data servers. So what is data servers? So the data servers are worked in the object-oriented database system. Already we have to see transaction server, which are used in the relational database system. So data servers are used in the object-oriented database system, so which used in the high speed LANs in cases where the clients are comparable in processing power to the server, the task to be executed or compute intensive. So here the data may be shipped to clients when processing is preformed and then shipped back to the server. So this architecture requires full backend functionality at the clients. So in transaction server architecture, all processes are done in the server only. But in the data servers, all the processes are done by the client only. So the server send the data. So the data are worked in the client and the result back to the server. So the both are differentially opposite. So in transaction server, the processes are done in the server. So in data server, the processes are done by the client machines. Here server only shipped the data only. So the data may be a particular item or it may be a page of items. If you want to, that means we have to ship the data from server to client is two types. Okay, first one is item shipping and another one is page shipping. So item shipping means the particular data, which data we have to want for the process, that data only they sent. So that is item shipping. But in page shipping, whole data we have to transfer from server to server to client. Whole pages will be transferred from server to client, that is page shipping. Okay, so this architecture requires full backend functionality at the clients. It used in many object-oriented databases. So the main issue is page shipping versus item shipping, locking, data caching and log caching, because the data are worked by the client machine. So more than one client taken the data from the server. So if you have to modify any data from the client side, so the data updation is main problem. That means concurrency. Concurrency is the main problem of this data server. So because every client has the cache data, so the cache data will be updated in all the system. So the cache concurrency is the main problem in the data servers. So already I said about page shipping versus item shipping. Page shipping, smaller unit of shipping, that means more messages worth. So here in page shipping, the data are all free fetching. Okay, so if you want to data or not, it will be free fetched whole pages. So free fetching is done in the page shipping. So the locking. So to overhead the concurrency problem, you have to lock. If you have taken the data from server, so a system lock the data. So the data will not available for other process. That is locking. So locks on free fetched item can be called back by the server and returned by client transaction if the pre-fetched item has not been used. So the locks on the page can be de-escalated to locks on items in the page when there are lock conflicts. So the locks on unused items can be then be returned to server. So what is data caching? What is lock caching? So data caching means the data can be cached at client even in between transaction, but check that the data is up to date before it is used. That is cache coherency. Already I said that. Check can be done when requesting lock on data item. If you have to remove the lock, means we have to check the data is updated in every databases, every users. So that is main concept. So lock caching. So locks can be retained by client system even in between transaction. Transaction can acquire cached locks locally without contacting server. The server call back locks from client when it receive conflicting lock requests. So the client returns lock once no local transaction is using it. Similar to de-escalation but across transactions. So the lock caching is very important topic in data server because it is the one of the way to rectify the cache concurrency problem. So next is parallel systems. Next we have to see parallel database system. So which consists of multiple processors and multiple disks connected by a fast interconnection network. So parallel systems are divided into two categories. One is coarse grained parallel machine. Another one is massively parallel or fine grained parallel machine. So in coarse grained parallel machine consists of a small number of powerful processors only. So which contains small number of processors. So the fine grained parallel machine utilizes thousands of smaller processors. So the parallel systems are performance are measured by two categories. So one is throughput, another one is response time. So throughput, which specifies the number of tasks that can be completed in a given time interval. So the response time specifies the amount of time it takes to complete a single task from the time it is submitted. So throughput specify number of tasks, response time specify amount of time. So the speed up and scale up are measured here. So the speed up, which is a fixed size problem executing on a smaller system, is given to a system which is n times larger. So the which measured by speed up is equal to small system elapsed time divided by large system elapsed time. Speed up is linear if equation equals n. Scale up means nothing but which increase the size of both the problem. So speed up increases the number of transaction speed. Speed up increases the transaction speed. Scale up increases the number of transactions. So which increase size of both the problem and the system. So the n times larger system used to perform n times largest job. So which measured by scale up is equal to small system, small problem elapsed time divided by big system, big problem elapsed time. The scale up is linear if equation equals 1. So that will be shown on this diagram. So the straight line goes to linear speed up, specifies the linear speed up. So the curve line specifies the sublinear speed up. That means, so the process occupy the number of resources correctly, so the speed up will be increased. So if we have resources allocations slightly reduced, then it will be the speed up will be reduces. Next diagram shows the scale up. So scale up means also the problem size increases. Now scale up also increased, but the problem size decreases, the scale up will be decreases. So scale up also specified into two categories, two types, batch and transaction scale up. So batch scale-up means a single large job which typical of most decision support queries and a scientific simulation which use an n times larger computer on n times larger problem. Transaction scale-up, so which specify numerous small queries submitted by independent users to a shared database. Typical transaction processing and time sharing system. So the n times has many users submitting requests to an n times larger database on an n times larger computer. It well suited for parallel execution. So what are the next we have to see what are the factors limiting speed up and scale up. So the main factor is short up cost. So the short up cost limiting the speed up and scale up, and also interference. So any interference will be occur, and also skew. Skew means we have not divide the problem into we have not allocate the firstly we have not divided the problem into same number of size. Yeah, so we have not divide the problem into same number of size, and also we have not allocated the resources equally. For example, if you have to allocate the resources equally, but the process is for example, a process is a process is a small process, a job is very small, but it allocated 50 resources. Another one job is very large process, but it also allocated resources 50. So this if you have to allocate in this type, so one small process have the 550 resources, and another big process also have the 50 resources, but the small job will be finished first. Okay, so the large stuff we have not completed. So this problems is called as skew, and that is increasing the degree of parallelism increases the variance in service times of parallelly executing tasks. So the overall execution time determined by the slowest of parallelly executing tasks. So how the systems are, we have to connect parallel databases, so more than one systems connected. So how the systems are connected, so that will be specified in the interconnection network architectures. So here I specify three different types of interconnection network architecture. First one is bus, next one mesh, third one is hypercube. So the bus system components send data on and receive data from a single communication bus, so it does not scale well with the increasing parallelism. So if a number of components are increased, it will not perform well. It will not perform well. So we have to come next we have to introduce mesh. Here the components are arranged as nodes in a grid format, and each component is connected to all other adjacent components. So if here what are the difficulty arise means, if the communication links grow with growing number of components and so scales better, but may require 2 to the power of n 2 root the n hops to send message to a node. Next we have to move on hypercube. So hypercube, the components are numbered in binary components, so are connected to one another if their binary representation differ in exactly 1 bit. So the n components are connected to log n other components and can reach each other via at most log n links, which reduces communication delays. So this is the diagram of interconnection architectures. So first one is bus. So serial communication will be available in the bus architecture. Next mesh. So this show the grid format. So every systems are called as nodes. So this form the grid format. So every adjacent nodes are connected. So third one is hypercubes. So the nodes are represented by the binary numbers. So the adjacent nodes have the exactly 1 bit are different. So next we have move on to parallel database architecture. So in parallel database architecture, it specifies 4 different types of architecture. First one is shared memory, second one shared disk, third one shared nothing, and the last one hierarchical. Shared memory, the name itself, is shared common memory. So all the processors share a common memory. Shared disk, all the processors share a common disk. Shared nothing means it doesn't share anything. So it share neither common memory nor common disk. So hierarchical means the hybrid of the above architectures. So this is the diagram of shared memory. First one represent the shared memory. So only one memory available there. Next one is shared disk. So every processor have the separate memories, but disk are shared. Shared nothing means every processor have the individual memory and also individual disk, that is shared nothing. So hierarchical, it will combination of shared memory or shared disk or shared nothing architecture. So first we have to see shared memory. So the processor and the disk have access to a common memory, typically via a bus or through an interconnection network. So extremely which provides efficient communication between processors. Data in shared memory can be accessed by any processor without having to move it using a software. So the disadvantage of shared memory is which architecture is not scalable beyond 32 or 64 processors, since the bus or the interconnection network becomes a bottleneck. It widely used for lower degrees of parallelism. That is 4 to 8 machines only, which is suitable. So next, shared disk. So all the processors can directly access all disk via an interconnection network. So but the processor have the private memories. Every processor have the individual memories. So the memory bus is not a bottleneck in this architecture. But the problem is fault tolerance. If a processor fails, the other processor can take over its task, since the databases reside on disk that are accessible from all processors. So examples of shared disk is IBM Sysplex and DEC clusters running RDB, variable commercial users. So the main disadvantage is interconnection to disk subsystem. So shared disk system can scale to somewhat large number of processors, but communication between processor is very slower. So next we have to move on to shared nothing. So the node consists of a processor, memory and one or more disk. Processor at one node communicate with another processor at another node using an interconnection network. So a node function as the server for the data on the disk or the disk node wants. So example of shared nothing architecture: Teradata, Tandem, Oracle NQ, that is. So the data accessed from local disk do not pass through the interconnection network, thereby minimizing the interference of resource sharing. So the shared nothing multiprocessor can be scaled up to thousands of processors without interference. So the main drawback of shared nothing architecture is cost of communication and a non-local disk access. So which sending data involves softer interaction at the both ends. So the final one is hierarchical, so which combines the characteristics of shared memory, shared disk and shared nothing architecture. So the top level is a shared nothing architecture. So the nodes connected by an interconnection network. So and do not share disk or memory with each other. Next, each node of the system could be a shared memory system with a few processors. Alternatively, each node could be a shared disk system, and each of the systems having a set of disks could be a shared memory system, which reduce the complexity of programming such systems by distributed virtual memory architectures. So the hierarchical architecture also called the non-uniform memory architecture, because top level is shared nothing and next level is shared memory and shared disk. So the So in this way this represents, so it is called as non-uniform memory architecture. So next we have to see distributed system. What is distributed system? So in distributed systems, the data are spreading over multiple machines. So the machines are referred as sites or nodes, anything. So the data are replicated in so much of devices. So that is distributed system. So here the network interconnects the machine. So the data shared by users on multiple machines. That is distributed system. So distributed databases. So we have two different types of distributed databases. One is homogeneous, another one is heterogeneous. So the data are reside in more than one system. So each and every one system have the same type of software or different types of software. If it uses same type of software and also database management scheme, means it specifies as homogeneous distributed databases. If the system have the different types of software and also different types of database management system, means which specifies as heterogeneous distributed databases. And also we have specified the transaction also differentiated into two categories. First one is local transaction and another one is global transaction. So local transaction means the data are processed in a single site, means which is called as local transaction. So if the data are used in more than one system, so that transaction will be specified as global transaction. So trades of in distributed system, what are the uses? Means sharing data. We have taken the data from any systems. So and then autonomy. So each site is able to retain a degree of control over data stored locally. So higher system availability through redundancy. But the disadvantages is software development cost, greater potential for bugs, and also increased processing overhead. What are the implementation issues available? Means, so the atomicity and so atomicity is the main problem for distributed database. To overcome the atomicity problems, here we use the 2PC. So 2PC means two-phase commit protocol. So both the from the client and servers, both side we have to commit. So that is called as 2PC. So using 2PC we have overcome the atomicity problem. So the last topic, we have to specify network data types. So we know about types of networks. We have different types of network. Basically we have local area networks, wide area networks, and metropolitan area networks. In this topic here I specify local area networks and wide area networks. So local area network means it cover small geographical areas. Wide area network means it distributed over a large geographical area. So which is specify the local area network. So the wireless area networks with continuous connections are needed to implementing distributors. For implementing distributed database system, we have used a wide area network. So groupware applications such as Lotus Notes can work on wireless area networks with discontinuous connections. So in these wireless area networks, the data is replicated and updates or propagated to replicas periodically. Copies of data may be updated independently, and non-serializable execution can thus result resolution in application dependent. So overall we have to see the database architectures. What are the different types of database system architecture are available? We have in this day we have to see the centralized client server architecture and transaction server architecture, data server architecture, and parallel database system architecture, and then distributed database system architecture. Finally, we have to see network types. Thank you.